Hi, so I'm recording this video for Coursera AI Project Management Specialization Course 2, where we have to discuss about a project, and the project topic is identify the defective parts on an assembly line and reduce the DPPM, that is defect parts per million by a value. This is the target. Okay, now the opportunity evaluation. This is the first criteria on which this particular problem is to be evaluated. Okay, and this is the introduction. So on our assembly line in the manufacturing unit, parts could become bad depending on various factors. Currently, these parts are normally inspected by random evaluations by human experts, and if a part is found defective, then we discard the entire batch. Human evaluations, though, is prone to errors, and hence sometimes defective parts end up delivered to customers. Using ML, we want to achieve following objectives. First, increase customer confidence by delivering better quality products. Decrease dependency on human experts for testing. Third, decrease DPPM value by rapid feedback of errors. Now, there are following three evaluation criteria that we have to cover. Is there a problem? Yes, obviously, as I have described, there is a problem. Can ML solve it? Yes, ML is a potential problem solver for this problem. We can use image processing to solve this problem. Does someone care? Obviously, there are customers involved, and company who is manufacturing the parts, they do care. And then the second criteria talks about crisp DM business understanding, and in which we have to cover these aspects. First is define the problem. So target user target user for this problem is line managers who are managing the assembly line. The problem that we are trying to solve is need to detect defective parts early and feedback quickly. Why it matters? It increases quality of the product process and wins customer confidence. Current state, manually done, it is prone to human error. And the success, how we can define success for this is expected impact. So impact is increase in quality and decrease in customer complaints. Metrics are outcome. We are trying to reduce the DPPM, and output of the model will be measured by AUC under ROC curve. Target is outcome like DPPM reduced by some percentage, and output AUC, the area under curve, should be greater than some excess percentage. Constraints, so defective parts should be reported immediately. This is one constraint that we are working on. Identify factors, though there are different factors which are involved. Some of the major factors are assembly line equipment. What kind of equipments are used on assembly line? What is the raw material used? What are the lighting conditions? What is the camera quality? And at what angles the image is taken? Then solution validation plan. So following is the solution validation plan. The manufactured parts will be videographed with 60-degree rotation, and the recorded video is divided into images. Then these images are processed by ML system to identify defective parts. We can use this sort of iteration where a prototype first is a simple CNN model will be presented with collected images of defective parts, and as we get more data, we'll keep refining this model continuously, and we'll keep retraining it to get increased accuracy and increased confidence. There are some ML system design considerations which we have to make. So first criteria is cloud versus edge. As this this problem is at edge end, so we have to keep it at edge. The images will be processed at edge, and we have to report the defects quickly, so latency is a major consideration in this. Offline learning versus online learning. So offline learning, it is going to be offline learning due to connectivity issues at edge. Model could be trained in offline mode and then deployed at edge. Batch prediction versus online prediction. So we want online prediction. Okay, the prediction is to be done in real time, and it is to be done for each inspected part. Potential risk in production. So first risk is training and serving issues. So if lighting condition changes or camera quality issues occur, then there can be a training serving issue. Okay, latency in prediction could be a major concern for us. So if for some reason like camera output is changed or camera output generates more images, then there can be latency in prediction. Data drift, due to change in manufacturing process, the model can become obsolete. So there may be completely change in machines which are there deployed at assembly line, or change in complete raw material. So that kind of changes can completely skew or make the model obsolete, and it will require retraining from scratch. Yeah. So yeah, this covers all the aspect which are required for this problem. Okay, thank you.